Bienvenidos. Bienvenue. Welcome to the presentation in JupyterLab and language extensions. My name is Gonzalo PeñaCastellanos. I'm currently a software engineer at QuantSight. I'm a Colombian living in Bogota. My background is in civil engineering and water resources. I've been doing open source development since 2014, and I've collaborated in different projects including Spider, Lecture, and Project Beware. I started working with Project Jupyter and specifically JupyterLab in 2020 in the topic that I will be talking today in this presentation. And just like Mr. Bean, I'm fluent in Spanish, English, and French, which was very useful when tackling this work. For the presentation today, we're going to have three parts. The first part, we're going to talk a bit about the background, some definitions, language and code, how the different system tools and standards interact. And the second part, we're going to talk about globalization in Project JupyterLab and how you can globalize your extensions. Next, we're going to talk about the interface, and I'm going to give you a small demo. And finally, I'm going to tell you how you can help the project and the different languages. This presentation is targeted at anyone who wants to learn about globalization in general, about globalization tools, and how it is applied to JupyterLab. So let's begin. Well, when we talk about internationalization, we refer to the operation by which we take a program or a set of programs and turn them into a package that is made aware and able to handle and support multiple languages. Being a long word, internationalization has often been shortened to I18N, where 18 stands for the number of letters between the I and the N. This process often requires changes to code, and in some cases rewriting how some of the text elements interact with each other. This is usually taken care of by the developer. And in this process, the developer also needs to define which system is going to be used for accomplishing internationalization in a software. What is localization? Well, when we talk about localization, we mean the operation by which a program that already has been internationalized, we take it and we adapt it so that it can handle input and output in a fashion which is correct for a given native language and the cultural habits of this language. This part is usually taken care of by translators. And also, similarly to internationalization, localization is shortened to L10N. What else is localization? Well, localization is currency format. This means the use of decimal or commas as the decimal separator. Also means what symbols are going to be used to separate in millions or thousands. And of course, the symbols for our currencies, the dollar sign, the euro sign, among others. Localization is also number format. So very similar to currency, but without the currency symbols. Localization is also date and time. This means having the representation of standard years, months, days, hours, minutes, and seconds, how we order these elements, and how we display them for different calendars. This could be Gregorian, Julian, Chinese lunar calendars, Ethiopian calendars, or even calendars that are not currently longer in use. Localization is also text direction. Are we reading the text from left to right, from right to left, or from top to bottom? And how are other symbols like numbers interacting with this text in different directions? Finally, localization is also collation. This means how do we order the different elements, characters, and symbols for a given language? When we take all of this plus translation, which is the process of making words or text from one language, the source language, to another, the target language, we get globalization, also known as G11N or localization. This is an iterative process. As we have seen, it begins with internationalization, where we do product design, product development, product testing, and quality assurance. When moving to localization, we might find issues, so we iterate and go back and forth. Why is this important? Well, if you're a commercial software company, you would like to reach a larger target audience. But the real question is, why is this important for open source? Well, first of all, we want people to actually be able to use our tools. We want to reach a larger audience as well, and in open source these have some benefits, like we can get more testing for our software, and we also have the possibility of having more contributors helping the project. But at the end of the day, what we want to do is we should strive to provide users with an experience that feels native, so that they are comfortable using our software and they can focus on the important things on their job. So let's continue. A lot of software starts its life being written in English. So let's talk a bit about how the English language works. English has letters. Letters make up words. Words make up sentences, and sentences make up paragraphs. Let's take this sentence from Squanchy. I like your squanch. And let's analyze a bit how this would look in different languages. Let's start with Spanish. In Spanish, we almost have a one-to-one translation. So, a mí me gusta tu squanch. And we could do the same process for French. J'aime ton squanch. However, it is important that we take a look at the third row, in which, depending on who are we talking to, the formality or informality of our conversation, we can use different words in Spanish. Also, it is worth noting that depending on a squanch being feminine or masculine, we might use different words, like ton or ta. Languages also have pluralization. That is, depending on the number of elements, we may use different pronouns, different endings for symbols, different verb conjugations. Let's take a look at a Polish example for the English word file. So with the help of the music box, we can get that when we have one file, one plik, well, this is how it's spelled. But take a look what happens when we have different numbers of files. So depending on if it's 2, 3, 4 or 5 to 21, the amount of files we have different endings on the word. So I guess this is how it will look for Mr. Mystics. Languages also involve gender. So to take an example from the French language, we can see that different countries in green have masculine gender and in purple have feminine gender. So for example, Colombia has feminine gender, so we would say la Colombie. To take again the Polish example, we now see that we also have neuter, that is neutral, and plural names. Languages also have context. What do we do when we have a word that is spelled the same way and sounds the same way? How do we know what it means, or how is it supposed to be used? Well, here's where context comes into play. What does the word tab mean to you? Is it a UI element or widget? Or perhaps it's a symbol that you use in your code editors, tabulation. Finally, if you're into music and string instruments, you may be thinking about tablatures. Finally, interpolation is when we have some text in code that we want to include as it changes on runtime. In this example, when we're closing a file, we get the text that says, do you want to close this? And the file name variable is going to change at runtime depending on the file that we actually have open. File name is a value that is defined at runtime. Let's continue. Now that we have seen some of the peculiarities of language in a very succinct way, let's see some of the system formats and standards out there helping to cope with language differences and globalization. The Unicode consortium, created in 1991, has one goal: to enable people around the world to use computers in any language by providing freely available specifications and data to form the foundation of software that will help internationalize major operating systems, search engines, applications, and of course, the World Wide Web. The Unicode consortium is in charge of maintaining the CLDR. More on that in a minute. And more importantly, something that humanity could not live without in the modern world: emojis. Let's talk about the CLDR. It stands for the Unicode Common Local Data Repository. It provides the key building blocks for software to support the world's languages with the largest and most extensive standard repository of local data available. What type of local data? Well, we can find language and territories. For instance, to define a language, we can use a 4-letter code. In the first case, for simplified Chinese, the CH stands for the Chinese language, whereas the CN stands for mainland China. In the case of traditional Chinese language, the prefix remains the same, CH standing for Chinese language, but then we have TW standing for Taiwan. The CLDR is also in charge of storing pluralization rules for different languages and the information on how to display languages on a given language, for instance, simplified Chinese in English and in simplified Chinese. It also holds the information to handle calendars and date formatting. Remember to look at the sources below to see more information on the things I'm presenting today. Now let's talk about the systems. Let's start with Gettext. It comes from the GNU project and is one of the older systems. It was originally targeted at providing tooling and globalization for developers, translators, and users using the C language. The Unicode consortium also created ICU, which stands for International Components for Unicode. And the target language for this one was C, C++, and Java originally. Finally, we have Fluent, a system created by Mozilla aiming at the web and used internally for their Firefox project. As they call it, a localization system for natural-sounding translations. All these systems and tooling rely on the CLDR data maintained by the Unicode consortium. They have solved problems found in the previous ones, and you can have many different blog posts talking about these systems and their strengths and the problems they solve. Let's talk about some of them. On Gettext, we don't have gender handling. It uses source strings as keys, which generates bilingual catalogs. This means you bundle both the source and the target language. In this example, for the source language, we have English with Hello World. That would act as the key or the identifier, and the value would be the French translation Salut Monde. For ICU, it does handle gender, but unlike Gettext, it uses ID as keys. These are often referred as monolingual catalogs, as they only store the identifier and the target language. They also provide custom formatters. Following the same example as before, we have the ID say hello unique key, and then we have the target value hello world in English and Salut Monde in French. Fluent also handles gender, also uses ID as keys, and also provides custom formatters, and on top of this, it addresses specific things for the modern web. Storing the key as a source string or as an ID has both advantages and disadvantages. On one side, depending on the length of the text, you can end up with large SAS files. On the other hand, when using IDs as keys, you will need to have separate file for the source language, English in these examples, and you have to go back and forth to find actual strings that correspond to an ID. Finding good identifier names can also be challenging. Looking at the language of the backend in the project JupyterLab, we have Python. Python, being C-based, chose Gettext as its system and is part of the standard library. A fun fact, Gettext and Python are also around 30 years old and started at the same time. ICU and Fluent also have available Python packages, but their usage seems to be very limited in the Python ecosystem. The front-end language of the JupyterLab project is JavaScript. Well, actually TypeScript, but it gets compiled to JavaScript. And in this world, there are many different libraries and frameworks and formats to take into account. Finding a solution that fits all the requirements proved to be a real challenge. On one side, we have jQuery and Jet that provide Gettext functionalities. We have Format.js, which provides ICU functionality, As mentioned before, we also have Fluent, which is kind of similar but not exactly as ICU. There are also frameworks devoted to provide partial localization functionality like Moment.js, and specific libraries that target frameworks like React, Angular, or Vue. I18 Next particularly seems to be a very powerful framework for handling different formats and systems. However, it required different plugins for each one of the frameworks you use, and this focus was only for the frontend, so we don't have I18 Next for the backend. Once you have defined a system or tool, now you have to take care of how you are going to share these different translation files. This could come in different flavors depending on the mobile platform you use, for example, either Android, iPhone, or Windows. You can actually have document types like text, Markdown, HTML, XML, and many others. Each software framework also may impose a set of formats that developers and translators will need to use. For instance, if you are developing a GUI application using the Qt framework, you are going to have to use a given format that they specify. And the list goes on and on and on. With this, we finish part 1 of dealing with some of the background and tools available. See you in part 2. With the background out of the way, it is time we focus on some of the considerations that went into selecting the tooling for globalization in JupyterLab. As mentioned before, the frontend of Jupyter is written in TypeScript, which gets compiled to vanilla JavaScript. On the other side, the server is based on Python and uses Tornado. These two components communicate via JSON. No, the other one. So there are different sources of documents that we have to take care of. There was some discussions on different things available, some that suggested taking care of some frameworks or modules using another one. Use IQ, but it's actually changing the format, so maybe we should wait. Fluent was not really mentioned, which doesn't mean it's not a valid choice. But something I wanted to highlight from ICU is that the use of curly braces resulted in some invalid TSX for some cases, and the alternative turned out to be very verbose. Some considerations in actual strings is that most of the codebase is one-to-one translations. Most of the entries themselves are short sentences and words. Pluralization was used only in a handful, as well as interpolation. So we wanted to really introduce very minimal changes in the codebase. Additional to this, we want to have an uniform style API for both backend and frontend. And although some components in JupyterLab core use React, we want other extension developers to be able to rely on any other framework. I18 Next seemed to be like a very robust choice, but it resulted in different plugins and syntax depending on the framework you had to work with. Also, this one was only focused on the front-end side of things. The tooling with Python around Gettext is huge, and in the server side, where most of the heavy lifting is taking place, where it seemed like the better fit. Also, translation platforms seem to favor and have much better support for Gettext. Although Gettext does have some deficiencies and puts an extra burden on the developer, one final consideration we wanted is to provide a very simple interface for translator and users helping with translation. Why is this important? Well, JupyterLab being an open source project, we want to rely on contributors and volunteers all around the world. So we need to crowdsource this effort. So at the end of the day, we pick up Gettext, which ticked most of the boxes, but a little bit more on the workflow in a minute. Let's talk about translation packs now. Actually, Mike suggested we also included spell check dictionaries since the concerns are related. This way, language packs would now provide not only translations, but spell check dictionaries. Nice going, Mike. The actual coding work on the front resulted in the creation of two packages, translation and translation extension. These provide a new token, the iTranslator, which is used by JupyterLab plugins. The result was the first PR that went into core. From the backend side of things in JupyterLab server, a new handler with a new API endpoint for translation was created to provide the list of available styled packages or the actual catalog for a given package. This resulted in the second PR. Finally, with initial tooling created, the code was updated to include the iTranslator and extensions and pass it down to class in constructors, to methods, and to components. This final PR was massive. Over 300 files were modified. Now, as promised, let's take a look at the resulting workflow. With the code adapted in Python TypeScript files, we start by extracting the different strings into a POT file, a portable object template. From this, we go into a PO file, which is basically a catalog for the target languages that we want to use. Finally, we compile these catalogs into JSON file and an MO file, a machine object file. The JSON file is served to the front end, and the MO file is used directly on the server by server-side extensions. So we actually needed at some point define the service we wanted to use for crowdsourcing. So there were many options, and we asked the NumPy project what their experience was with this, and they made a suggestion. They said, we use Crowdin. We tested our options, and we actually like Crowdin a lot. It provides a great and simple interface, excellent support for Gettext, and a great integration with GitHub. With the current state of different languages, Simplified Chinese was the first one to achieve complete localization of the core JupyterLab. We now have over 100 members helping in a bunch of different languages, which resulted in the creation of two tools. The whole process first yielded the Jupyter translation package, which is in charge of doing extraction, creation of catalogs, and compilation to JSON and MO files. The second tool is actually the language packs repository, which bundles in a single place translations for core and third-party extensions. Having this monorepo greatly simplified the workflow and the process and made it very easy to contribute. Revisiting the workflow, now we can see that the JupyterLab Translate package is in charge of all the gray arrows. And you may be wondering, okay, so where is Crowdin fitting? Well, Crowdin fits with the portable objects and the direct integration with GitHub. Having seen this, it's now time for a short demo. So let's take a quick look of how the new language settings work. If you go to the settings menu, you will see the language submenu. Once you have installed a language pack, it will become available in that menu. I have already installed the Chinese simplified language pack for this example. This is the language pack with most coverage at the moment. You can select it and it will ask you to refresh the interface. And there we go. So now this is JupyterLab available in Chinese. Currently, we have to install this manually on the server side, either via the terminal or any other way, but there is work in progress so that we will be able to install language packs directly from the extension manager. For the project Jupyter, you can select your language. Let's say we go with Spanish, and it will display all the different POT catalogs available. So we have the JupyterLab one for core, and we also have one for JupyterLab Git and the last lab extension. If we wanted to help translate the JupyterLab core, which currently for Spanish is at 50%, we can just left click on the link and we'll be taken to the translation interface of Crowdin. In here you will see in red all the translations that are missing translation and in green the ones that have already been translated. You will get information on the context of the file, where it comes from, and you also get information and some help on potential candidates for the translation. You can enter your translation here, and finally, if you have questions or comments, you can also use them here. Crowdin also has the functionality to add screenshots. That is, we can add screenshots of different places in the configuration, and this will be referenced after OCR is performed on the images on the different parts of the translation interface. This provides a lot of context for translators when they want to know exactly where a word is coming from. Now let's see how you can help JupyterLab. So you're probably wondering how you can help. Well, this project cannot continue without your help. Yes, your help. And maybe you're wondering what you can do. Well, first you can go to Crowdin, pick a language, and start translating. The interface is quite clean and friendly and easy for users to contribute without any previous knowledge of development. You can also go to Crowdin, then pick a language, and help us proofread. With many different contributors, the style of a translation might change from person to person, so reviewing the work of others and making sure that the style is consistent is very important. If you have questions or need clarifications, you can use the embedded comment section on the right of the interface. You can also go to Crowdin, then pick a language and help us create glossaries and maintain them. These are the definitions of some technical terms that aid collaborators in the translation process. You can help them define styles, guides, to keep consistency as mentioned before. On top of this, you can also help localize your favorite third-party extensions. To do this, you first need to open a pull request by reading the documentation on how to do this, and more importantly, by looking at code examples in the JupyterLab repository examples directory, as well as the extension examples repository. These two are invaluable sources in understanding how to globalize your extensions. Finally, you will open a pull request on the language package repository and add to the repository map YAML file the following things. First, you need to provide the name of the package, then you need to provide the URL to the repository, and finally a tag to the version that included the internationalization changes you helped make. I would like to acknowledge the help that different people that helped during the period of many months with this globalization effort. I would also like to thank you for joining me today in sharing this brief summary of the journey, and I wish you have a great day and please enjoy the rest of the conference. See ya!